Megan, you're in with Dave, and you should be set up as a presenter. So, Dave, if you want to just check the audio, we'll do an audio check.
Yep. Test 1, 2, 3. Welcome everyone to today's session.
Excellent. All right, so let's get started. Thank you. We're now all ready to go. We're here in the film studio with Dave Giles and myself, Nathan Becky. We're here to talk about beyond Ohm's Law using the CL1919 Conslab Ohm's Law trainer for EV training. And we're going to start just by talking a little bit about how many people see and think about EVs. We look at a modern Tesla like the one behind Dave and the one up on the screen, and the immediate reflex is to think about it's all electrical. All the systems are electrical. There are huge systems integration going on. There are large multiplex networks on the vehicles. There are many modems involved and GPS systems. It's like an Internet of Things device. So there's much integration with applications. There's infotainment, ADAS, and autonomous driving. And we often have the reflex to then think immediately about the systems and go into great depth and start rambling off on all the jargon and all the latest and greatest things. So we talk about BMSs and PCSs, high voltage interlock loop, three-phase motors, 1,000 volts, 48-volt systems, lithium-ion batteries. And a lot of times it's really exciting and really fun to talk about this, but we end up losing a lot of students along the way. And today's webinar, we're talking about really basics. It's not all about 48 volts and three-phase and complex systems. We can still keep it simple. The basics still apply. You can use what you know, you can use what you have, and you can focus on the fundamentals. Many technicians just need to know how to interact safely with the vehicle. This applies to all of your students. And we're seeing this being reflected in the certifications that are coming out. Throughout all of our webinars, there have been many, many questions to us about certifications, and there are two ones that we want to speak to today. There's the CSA group has just launched a new automotive electric vehicle technician certification that is now available, and there is the ASC XEV certification. And we're seeing this reflect really what we've been seeing across schools and across the industry is there's two ends of the spectrum. We have the very, very high level, very high technology, advanced level for the technician. So this is something like they're doing with the CSA group. And I've provided the link there for this certification. But this is something that has high level prerequisites. It's a high level exam. This is for experienced master technicians. You need a lot of baggage to go in to do this certification. And it's very much recommended for instructors. But there is quite a bit of cost to it. Then at the other end, we have for students, what we're seeing more and more of is the ASC XEV, which is electrified propulsion vehicle. So that touches hybrid, that touches EVs, that touches even if you look at a plug-in hybrid or hydrogen fuel cell vehicle that is also, by the way, electrically driven. And these are certificates or certifications that your students could go and do. And this brings us back to the level that we're talking to today, which is let's look at the basics, let's focus on safety. And now Dave's going to show you guys what we're able to do with the Ohm's Law trainer. So we're going to do 5 different circuit setups that we can demonstrate on this. And I'll let Dave give a little intro, and I'm going to swap from screen sharing to now Megan is going to take over the control.
Welcome everyone. Today we are using what we call CL1919 Ohm's Law trainer. It's a trainer typically used in electrical classes to teach students about Ohm's Law, circuit designs and so on. But what we've noticed or what we've realized is that some of the fundamentals that we deal with in high voltage vehicles, whether it's in safety or demonstrating how components and systems work, we went back to the Ohm's Law trainer and realized that a lot of the circuits that are integrated into an electric vehicle can be demonstrated easily with the Ohm's Law trainer, such as one like this. So today we're focusing mainly on this trainer. There is a sheet, I believe, that will show all the different setups and that, and I think we're going to send that out to everyone. So as well as the PowerPoint is designed to walk through the layout for each one of them. So I'm going to create almost like a story as I go through, set this up. I'll show the exact layout, how it works, and what you can demonstrate with it. So there's various different ones we're going to do. Like I said, there's 5 that we have. And the cool thing about this is it's all about innovation and how we demonstrate it. So whether we use the 1919 in the way that I'm going to show you today, you may come up with new ways of doing it. So I'm hoping this sparks some, some intuitiveness into these types of products that you can continue to take them from, the early levels of your apprenticeship or your program and bring them right into your, even into your EV training or your high-tech training that you might be doing on these types of systems. So we're going to start off today with Regen, and Nathan will give a little introduction to that.
Yes, so regenerative braking is something that we talk about when teaching EVs, that we talk about with hybrids, and it is one of the main advantages really between an electrically propulsed or electrically driven vehicle and a combustion powered vehicle, where the combustion engine drives the wheels directly. So this regen braking, we have to remember, this is the same regen braking you would have on a hydrogen powered Toyota Mirai, to a plug-in hybrid electric vehicle, to a hybrid, to a Tesla or a Nissan Leaf. And really, this is one of the main advantages that we see is whenever we're braking, we're going to be capturing back that energy. So this is something that's crucial to explain to students. And Dave has found a very innovative way to demonstrate this using our Ohm's Law trainer. So
great. So this would be like a diagram that we would start with. And with the regen trainer, it's important that not only that we show how it works, but the function of regen and how we can capture it, whether in a visual state or using different types of our test tools. So I'm going to be using a meter, I'm going to be using a lab scope, but more importantly, I don't need those. I can actually just use the Ohm's Law trainer to demonstrate it. So we're going to get started with setup on this. So we're going to start wiring this unit up. And we'll start with the first set of leads. Yep. So you need to.
All right. So.
Okay. So I'm going to start off by powering the unit up. So I'm going to start wiring up before I power it up. In fact, I'm going to leave the unit off until I finish wiring the entire circuit, and then we'll turn it on. It's going to be about full voltage on this unit itself. So I'm going to take it, I'm just going to follow through the diagram to wire up this trainer. So I'm just going through each one. And I've fused the circuit because I want to protect it. I'm going to go start with the input on the switch, make sure the switch is off. And then I'm going to continue on with my ground circuit to the motor because I want to demonstrate the regen. So we're going to use our motor that's on the unit itself. And then I'm going to take it to a portion of a relay. And I'm going to finish wiring this guy up. Okay, and we have the here. Just gonna get my wiring up here. You guys had it. They jumped around on my my thing here, so I'm just gonna try and get this. So I'm gonna be using the buzzer and the LED light to demonstrate this. This functional reason is because the LED light responds very quickly, and it'll show with and without regen on the system itself. So it'll make it a lot easier to be able to demonstrate that. So I'm just going to continue to wire this up. I'm going to use my pulse width modulation control for the throttle on this unit. So I'm going to go down to my pin 86 here, and I'm going to continue to wire in my ground circuit here, and I have my switch going into my 30. And then I'm going to take, so anyways, yeah, we can jump to the next one there. I believe I'm kind of getting there. and there should be more. Yeah, okay. So I just want to finish wiring this up. Okay, it looks like a big mess here. I'm just gonna go one more. Oh, okay, so I'm just gonna check my circuit here because we had a glitch in what we were doing. So I'm gonna follow my power through my fuse to my switch. My switch is off right now. I'm going to go up into 30 from my switch for full voltage. Then I'm going to be controlling it with my my pulse width modulation here on the 86. I got my ground lead going to ground here. I'm taking my 30 from that switch and then going out to my motor from the switch itself, which then also I'm using the light and the buzzer to demonstrate. Now I don't have to use the light and buzzer. I could use a meter or a scope on this point, but I'm going to do it both ways. And then from there, I have my powering the entire unit. So now I'm going to turn the unit on. My throttle, I'm going to use this as my throttle here. Right now it's turned off and everything is off right now. I'm going to turn the unit on. And as I increase in, we can hear it running. So I'm using this as my throttle. So I see the motors running and I see the light going. I'm using the light to demonstrate the system on. But one thing I want to show is when I turn the throttle down, you'll see that the light dims down. And this is important to use the LED for this. It just shows a little bit faster response with that circuit. So I see it again, I'm controlling it. As I turn it down, it goes down. So that means that that light is dissipating very slowly. I don't have any capacitors on here. So the only way it's doing that is getting energy from somewhere else when I shut the throttle off. So if I do this quickly, and you'll see the light dimming down. One thing I like to demonstrate to show the students that the electric motor is generating energy even after I shut that throttle off on my pulse width modulation is if I take the motor out of the picture and just do it, you'll see the light is almost instantaneous. So by adding the light to it, or the motor to it, I can see that it dissipates the energy very slowly. Now, what's really cool about this is I could use a meter. So I could use the meter that's on the unit. Oops.
So while Dave is doing that, if we show up here the screen, so I'll walk you through. So what Dave has done is using the Ohm's law, CL 1919, and you could do this with any train. It doesn't have to be a console. You could do this with components, electronic components, is connected the circuit in such a way as we have on the schematic here, that when the motor is in the circuit and using the pulse width modulation to bring the motor up to speed, as we decelerate, we can see the light slowly goes out. So we can demonstrate there's continuous flow. And then when he takes the motor out of the circuit, what happens is it can immediately go out. So we can see how it's a visual, and there's also a buzzer that's connected to the circuit. So it allows us to see the movement, see the light turning on, showing the energy, hear it through the buzzer, and we can use this to teach the basic principles of regenerative braking using this Ohm's law, building that circuit.
Okay, so what I have here is I'm going to put the scope on here. It's going to turn down the time on this, and you'll be able to see and actually be able to see the slope from the scope. So I'm just going to get set up here. And so what I'm going to do is just show real quickly how it's just dropping out. You see the energy from the scope itself. It just kind of drops slowly down. A multimeter it's not as easy to see that. And one thing I want to show here is if I go into, I take a little bit lower voltage here. I'll go down, you'll see it kind of just dissipates out. But when I take the motor out of the picture, it becomes it's like a switch almost. So it shows that the energy that's coming in and out of the motor is actually generating some energy as I do that. And of course, even as I turn the motor, I can see that it's also a generator as well too. So this is a quick example of using the 1919 to show a quick overview of how regen works. It allows the students to wire it up and practice circuit and following the diagram as well, but also being able to demonstrate how the system works. So we're going to move on to our second one.
Yes, so the second one we're going to be talking about is teaching the hybrid drive mode. Okay, so this is a similar circuit that Dave has created using the Ohm's Law trainer. So now while Dave is wiring that up, and Megan, we could do the picture-in-picture, should work beautifully now. So while Dave is wiring this up, I'm going to pull up the schematic here, and we're going to start walking you through the circuit. So first off, we're going to be bringing power from the power supply down to the fuse and a ground up to the motor. Then we're going to go from the fuse to switch number 1. We're going to bring a ground to light bulb number 2. Then we'll be bringing power from switch 1 up through a resistance. A second power circuit comes through to feed the push button. I think many of you are going to catch on to how this is going to work now. So from the push button, we bring power to the other side of the resistor, which is then brought to the light bulb. And we connect in parallel the motor to that circuit. So Dave, we're ready now for you. We'll walk through those steps.
So that's going to be important as well to use it for, for the demonstration that you're going to do. So I'm just going to quickly wire this up here, get this in place. Okay. And you see I'm using the light bulb, and you'll see why I'm using the light bulb. In fact, the light bulb is to represent the power that's going to be coming from the hybrid mode of the circuit. So and I'm using resistor 3 for a reason. So on this board, and I'm also including the switch in with this circuit as well too. Okay. Okay. We're good. So what I'm going to do now is I'm going to turn my switches off, and I'm going to turn the unit on. So I'm using the same voltage as I did before, 14.2 whatever max voltage on the unit. Really doesn't matter. You can go a little bit less, but I like most because there's also some unique sounds that this will make just from the motor and so on. So I'm going to turn this on right now. So what this is happening right now is demonstrating ICE mode. This is regular power mode with the vehicle. You can see that with the ICE powered system or combustion powered system, I'm running not at full power. I'm running with the vehicle, driving down the highway. I got power to the motor. I can actually hear it there. But also this hybrid vehicle needs to pass a truck or something like that. So now they need to accelerate. And typically in hybrid vehicles, because the instantaneous power to the stator of the electric motor will boost that vehicle very quickly to help pass that vehicle. So in the case this is why I put the switch here, is that it allows you to show what happens when you push that accelerator, you need to pass the vehicle, you get that power from the battery to the motor, and basically, and you can actually hear the motor increase.
So it's really interesting because as you guys can see, when we pull up the schematic, whenever Dave presses down the push button here, we're giving full voltage through all the way to the motor and to the light. So the students can see just the difference of what happens when on a hybrid vehicle and the internal combustion engine is just chugging along, and then we engage one of the electric motors to give it kind of a boost, to give it fuller acceleration. That's what we're demonstrating here. And the students can both see it with the light bulb and they can hear it with the motor.
Okay. Okay, so we see once again you can hear the electric motor increasing. So once again, it's a great way. Obviously, we're using lower voltage to the bulb, but it's a way of showing that a combustion engine will have lower power to become more efficient driving down the road, and then it's going to utilize the electric boost power from the battery to get that vehicle up to speed and then return back to the combustion engine. So essentially, I'm passing that truck right now. I floored the accelerator. I'm going past the vehicle, and then now I let off, and it returns back to RPM normal, the engine, making the most efficient way of operating the system. So very important that we can see how hybrid systems work. And it's a very simple circuit to design and build for your students.
Absolutely. So while Dave prepares for the next circuit, which the next circuit we're going to demonstrate is the teaching of contactors and precharge, I just wanted to open it up that for those first two circuits, if you guys had any questions, now would be a good time to put them in the Q&A around those two circuits before we move along. So this is regarding both the hybrid circuits and the regen. One of the questions that already came up is that will this be recorded and posted? Yes, this webinar is recorded and will be posted to our YouTube channel. And these resources, these schematics for each of these circuits, we'll also put them up on our website, and we'll put a link and send it out to you guys so that you can get access to these schematics. So now that we've got the next circuit we're going to start working on, we'll bring this up here. What we're going to talk about next is teaching contactors and precharge. So this are those big, contactors on an electric vehicle on the battery. So we can have them called an SMR, a system main relay, on many of the Toyotas. Teslas is called some contactors, but there are always three. So we're going to see one on the positive side, one on the negative side, and then there's this principle of precharge. And the precharge is, of course, to prevent the inrush of current into the system. So we're going to turn on a contactor through a resistor, turn on another one, and then wait a moment and turn on the third contactor and switch over. Now the vehicle is going to be ready to run. So Dave has designed a schematic here. So we'll bring this up, and the first wires on the schematic coming in.
Thanks, Nathan. Actually, we'll follow along with this. Yeah. This is probably one of my favorite circuits. It really demonstrates, it really aligns. Because 1919 only has one relay, it doesn't take away from being able to demonstrate that, because essentially when you turn on and power up an electric vehicle, the one contactor, negative contactor, will turn on automatically. It just turns on, whether negative or positive, doesn't matter. Precharge circuits can be found on either or. So what we've done is we kind of demonstrated how that precharge circuit works. Essentially, the idea is a precharge circuit will charge the capacitors to prevent the inrush of energy from a collapse or from energizing that circuit, especially if a system's been off for a couple of days and so on, that it's now the capacitors have basically wore down. And now when you go to repower them up, if that huge amount of energy coming in very quickly can damage components very quickly. So the precharge circuit is very important in high voltage systems. So with this in mind, basically taking it and wiring it through its circuit to be able to demonstrate that to a student and show them exactly how that precharge circuit actually operates. So, and like Nathan showed a little picture there of a precharge circuit off one of our other trainers. It shows that, how there's that delay, how it takes a few moments before it actually turns on the full power to that circuit. So in this case here, we're going to be using, there's no capacitors on this board. So, and in fact, when I first did this, I actually used a real capacitor. I had a capacitor up here and I was pre-charging that capacitor. But then I realized that, it didn't add any value to the learning. And I'm demonstrating that with basically the light bulb on the circuit itself. So what I'm going to do is I'm just going to continue to wire this guy up here. I'm going to use the 194 bulb on the trainer or the L2 bulb. I'm going to go down to the switch here and finish wiring these guys up. So I have power coming into the relay. So you see, this is going to be kind of like my main contactor right here, my positive side contactor on this circuit. So I'm going to use this guy as essentially my power flow to that circuit. I'm going to put my resistor, I'm using resistor 5 as well as resistor 4 on this circuit as well too, just to enhance and increase the resistance. Typically, most EVs will use anywhere from 20 to 30 ohms, with probably about at least a 1 watt, if not bigger, resistance in that circuit. So with that said, I'm going to continue on. Finish the wiring up. I think I got pretty much everybody on here. And one more, 87. Okay, so I'm going to leave my switch off. So I just want to make sure I demonstrate something here with these switches, is that I have 2 switches I put in play here. One is to represent basically the push start on the vehicle, and the other one is my ignition switch. So when I turn this unit on, I'm going to simulate as if I'm going to start the vehicle and basically get into ready mode. So that vehicle. So I'm going to turn the power on the unit. Wait for powering up here. So I got 14.2 volts here. And what I'm going to do is I'm going to push the button down. And oops, I might not have something on here, right? Okay, there we go. Okay. So what I'm going to do is I'm going to push my finger down on the button here. As you can see, I'm pre-charging the circuit. So it'd be the same as me basically, pushing my foot down the brake pedal, turning the ignition on, waiting for that delay. As we can see, we have low voltage, and that's what happens to all these pre-charged circuits. I'm going through the resistors to that circuit, the light's low, and then when I release, I get full power to that circuit. So it's really showing that, rather than having that inrush. So it's really important. And one of the neat things with this is that if I watch the voltages on this, and it's something you can tell students as well, when you're showing this and why a pre-charge circuit works the way it does. I think I can see that on the meter there. Okay, so when I'm going to put back into pre-charge, we see I have 9.32 volts. So I've gone from 0 to 9 volts into that light bulb. So I have less voltage, a little bit less current there. And then when I release it, it gives me the rest of the voltage. So now I've gone 9 to 14 volts. So I've gone another 5 volts about. So it's like it's stepping that voltage up so it doesn't shock it as if I was just going to take it and put it directly to power. So, and then that means that the bulb would go from 0 to 14.2 volts. Right now, I'm actually staging that voltage and doing it that way. So, and this is kind of why they call it a pre-charged circuit. I'm pre-charging it with lower voltage and then giving it the remaining voltage for that circuit in order for it to operate. Okay.
Excellent. That's another wonderful demo that we can use for teaching. One of the really common systems that are across all electrically driven vehicles, and we can demonstrate those principles using a basic electrical trainer that most schools already have. Again, whether it's a Consulab one or from another company or from one that you built your own or just using some electrical components you had in the shop, you can do a live demo, have your students measure it and understand it to lead them to how the system works on the EV. The next circuit that we're going to talk about is HVIL. So this is one that I've always found very interesting because from a learning perspective, if you teach HVIL, high voltage interlock loop circuits from Tesla or others, you're essentially teaching voltage drops, and you're essentially, without saying so to your students, if they understand how an HVIL circuit works, they will understand how voltage drops work, because that is what it is, and that is how it works. So we have a couple examples here, from Tesla service mode on the left, and a schematic version of that. And now Dave's going to show us his version that he's done on the Ohm's Law Trainer.
So once again, yes, we have our Ohm's Law Trainer 1919. I'm going to basically leave it powered off until I finish creating the circuit. But it's an important circuit for EVs because obviously if there's a break in any of the connectors in the vehicle, it will disable the high voltage system, thinking there's something unplugged and not protected. So what I'm going to do right now is I'm going to start wiring this up to demonstrate the HVIL circuit. What's really cool about this circuit, though, is you can actually measure it. If you go into service information, I'm going to use the example of Tesla. If you haven't been on Tesla's service information, it's really great. It's free. They have videos, they have schematics, wiring diagrams, and so on. Just go to service.tesla.com. You don't need an account. You don't need to pay for a subscription. Go directly on it, and then you can access the information for any of Tesla models of the electric vehicles. I believe even the Cybertruck is up there now. So I'm going to continue to wire this guy up as I talk. And like I said, it's one of these types of circuits that's an easy, very simple circuit. Like Nathan says, there's a lot of, talking about voltage drops and how the system monitors is also an interesting way. Like, how does it know in some cases where that break is in the circuit? So, once again, it's an important circuit for EVs. And it's important to teach the simplicity of that, but also the testability of these types of circuits. So I can continue on. One thing I want to make sure I didn't say this at the beginning, is that I do have one thing is that as we wire these up, I actually, when you get the document, it'll tell you how many leads you need to use. So obviously, if you use less leads and it's not working, you may be missing one of the steps there too. So I'm just going to go through these two resistors. These two resistors are to represent basically components within the system. I could have an inverter here, and this one could be, a PTC heater of some sort. It could be, a cover on something that protects high voltage. So once again, so I'm using these here as basically components within that circuit. So in this area right now, these are my components in that circuit. And then I can continue on with my setup here for my wiring. And so I think we got her. I think that's all we have. Perfect. Okay, so what we have is we have our HVIL circuit diagram. I'm going to power the unit on. And now I can do this with different voltages. Obviously, we know that in some cases that we have, HVIL circuits are, basically a 5-volt circuit, can be a little bit higher. But the thing is, I'm just going with 14.19 because I want to demonstrate with the nice bright lights there how this circuit works. So right now, by going through this circuit, I'm going through two resistors and then up to the lights to indicate what they're going to do if they're driving, turning on a controllers, and so on. So these would be representative of the connectors. These are the controllers. But what's really cool with this as well is I can take my meter, and if you follow some of the service information, they talk about the voltage drops at different points within the circuit to be able to test the HVIL circuit. So in a quick sense, I can actually do a very quick test and actually measure, first off, voltages within that circuit. So I can see as I come out of the switch here, I go to the beginning here, so I get my 11.85, and then I go down to the R4 on the out of that, 9.5, and so on. So if there was ever a break in the circuit, the computer is actually, some of the modules will even monitor the HVIL circuit to tell where the break is, and sometimes it can be very specific. Others may just say it might be inside or outside of some of the components, but once again, it gives you a quick way of referencing the HVIL and how it works within that circuit itself.
So So I just want to talk a little bit about that HVIL because I find it quite fascinating, the way that the manufacturers are doing it. So again, what they're doing is using a reference voltage and a reference current source and driving it through all of these components. And I know, Dave, we have a couple harnesses laying around. There's an orange one over there we could grab just to show people what we talk about with that HVIL. Because in each one of these components, when Dave was showing on the circuit that when a component is disconnected, it's essentially removed from that loop. Inside of each of these orange connectors, Dave's got one up there now in his hand. So any high voltage connector that you see on these vehicles, go out in your shop, in your school, grab one and take a look inside. There are the large wires for the conductors. We'll get a better image there after a second. Yeah. And inside each one, even if we grab the disconnect off the prototype, Dave, if you want to grab the disconnect, it's got a really good image of it. So when these components are disconnected, it's almost like airbag shorting bar. It's not the same exactly, but it completes the circuit, and then the computer is monitoring the voltage drop and monitoring the current flow, and it can tell when something is disconnected. So Dave's grabbed a big disconnect here. These things are really cool. And you can see those two large connectors, and right in the middle, if we get it just so, you'll probably be able to see there's these tiny little pins. Right there we go. We got it. You can see just a little bit of the tiny pins there in the middle. We'll full screen that for a second. And you can see those tiny pins. That's the high voltage interlock loop circuit. So that one there is a generic one. The other one that Dave's got on the table, it's off of a Nissan, I believe. And so this can also be an activity that you could give your students, even on dead components. If you have a whole bunch of EV components or hybrid components around your school without the car being there, you could still have them do a student exercise, walk through and identify the terminals, the high voltage interlock terminals on all of the connectors, and then assess and analyze the circuit. And they could reproduce a version of the circuit like we just did using the Ohm's Law trainer. So this schematic here shows us how a very simplified version of a high voltage interlock loop. And then you can have your students go through with the multimeter, measure voltage drops across each one of these circuits and see how it works, how the voltage drops build up to the maximum of what the reference voltage is. It's very, very, very interesting and a very great learning opportunity for your students.
Yeah, and the other thing I like to add is that I use two resistors here. Just because these two resistors on this board are the exact same. But the thing is, you could add more resistance. You could use a pot. You could do different things with it to manipulate the circuit a bit. So based on the voltage drop, you could identify different components as if they were going to do, something different on the high voltage system for that interlock loop. So it's really a great way of the foundation of the wiring is here, but you can also expand on it as well too.
So the next step that we're going to do is a circuit, and we're going to talk about multimeter use. And this is something I've talked to many instructors. In fact, we had an instructor who was visiting us. We had many instructors visiting us in this past week here at Consulab, but one in particular, we were talking about how, as instructors and technicians, when we really understand how a multimeter works, we use a multimeter for measuring volts and amps and ohms. We measure, voltage, current flow, and resistance. And when we talk about Ohm's law, we're always talking about the math behind it and the principles of Ohm's law. And very few students grasp the concept, nor technicians grasp the concept that the multimeter, as it performs its various functions of measuring voltage, measuring current, or measuring resistance, it's all just measuring volts in a different way, in a little bit different configuration, and doing the math for you. So Dave has, this is probably, it's a really fun circuit to build. We're going to show you this. Follow along with the schematic. You need, how many meters do you have, Dave? When you walked in here,
only
you had
really
like
need
5 of them
one
in your
extra
pocket, I
meter.
swear.
I had the second one to show the voltage divider. So
you need 3 meters?
You need 2 to do it, but 3
3 is better.
ideally would be a neat, just because I want to show what happens to the voltage. Student might ask you, where's the rest of the voltage? So
Yeah. And of course, I know you're going to explain this, but I really want to hear your explanation of how you're externalizing this multimeter for everyone and really making it, building a multimeter. How to get, the way we titled it was how to get ohms from volts. And it's so fascinating.
So one of the things that that we do always have is that, students will go and measure resistors. So I have some resistors here, very simple resistors, and it's easy. They can go and they can measure across the 2 leads and, get a resistance value and do different things. But it's kind of fun when they actually have to apply Ohm's law to the actual the calculation. They're actually doing the calculation. So what we want to do is show how that calculation is created inside the meter, but doing it external. So they can actually do the measurements, they can do the testing. In fact, Nathan said 3 meters. Sometimes I'll even add a 4th meter just to validate so what they see. So for example, after they get their calculation, they get a number, and then they take another meter and they actually physically test it using their own tester to actually see it. Now the difference with this trainer, I am actually going down to 8 volts. So I'm going to take it to 8 volts. You can go a little lower, but be aware if you know and you use multimeters and you do go on the ohm scale and you start ranging through that scale, you'll notice that the meter that you're measuring it against on voltage changes voltage. So as Nathan said, it's nothing more than applied voltage, looking at voltage drop within inside the meter and calculating it with the current, basically a simple Ohm's law calculation. So we're going to show how this works within this tool. So I'm going to start wiring this thing up. So I'm using 3 meters here on this one. I have my voltage, my amperage, and another voltage meter. So I'm going to do it, and it's very simple. In fact, and I hate to say this because obviously with ContiLab here, but all you need is a fixed resistor to do this test. So if I had a fixed resistor, I'm using R1 just because of the calculation. It's a 100 ohm resistor on this board. But nice thing is I can set it up pretty easy for students to be able to do these calculations. So anyways, I'm going to start my wiring up my schematic. So I'm going to take it through the amp scale here on this meter. So this meter is going to be turned to amperage. So I'm going to have my current flow going through this meter down to my resistor. And then I'm going to be measuring essentially the voltage drop on this resistor as well too. So I'm going to incorporate my other meter here, and I need my ground lead. So this meter is going to essentially measure voltage. So I'm going to take this here, measure that there, and I'm going to take my red lead. So you can see I have a red lead that's just kind of hanging around. So I'm going to leave that down right now. And then I'm going to take my black lead. And this is why it's really good that we're going to give, essentially give what our layout is for this, because it makes it easier to understand and what we're actually doing here. So I do is I have my meter wired into this meter itself. Up. And I think I got pretty much what I need back in through. I'm just going to double check everything back through here.
So as Dave said, you can do this, of course, using the Ohm's law trainer. You can also do this just using ideally a 100 ohm resistor, because it'll make very easy math for your students. But 3 meters and a 100 ohm resistor, and you can teach what's inside of a multimeter.
Okay, I have one lead. Just going to get out here. I'm going to take it this way. Okay. What I've done is I've just changed it up a tiny little bit here, which is fine. So what I do is I have essentially 2 leads, just like a regular multimeter would. So what I'm going to do is I'm going to turn these guys on. I'm going to turn this one on to voltage, I'm going to turn this one on to amperage. I'll turn the little lights on. Not sure how much you can see of the meter screens. That's okay. I'm going to call it to Nathan so he can do the calculation, which you'll see on screen. I'm going to turn this one to voltage. So right now we see I have 8.05 volts on this one meter here, 0 amps, 0 voltage drop on that meter. When I take the two leads, and this is a great way of validating this, when I touch these together, then I see all my voltage is now dropped across that resistor. I got 8.01 volts here because I have no resistance across my touch leads. And this circuit's drawing about 0.079 amps. That's because of my 100 ohm resistor. So I'm ready for some testing. So within the board, there's multiple resistors in this board. So I'm going to go to the first one. I'm going to go to I'll go to R2. Why not? Let's go R2 here. I'll go across R2. Now it tells me, and why I have the second meter here, which isn't really critical, but it shows I have 2.25 volts drop across what I'm measuring. The remaining voltage is 5.770, which essentially is what the calculation of the meter is going to do with a draw of 0.056. So if I plug this into my calculator, I'm going to plug in 2.258 divide by 0.057. And of course, it'll give me about 40 ohms. So now what's really cool with this tool is that I can now I'm going to unplug my leads that I made, and the student can actually go back and take a meter and actually measure across that resistor to get that resistance on that lead. So
this is where the last time I remember, Dave, you pulled another meter out of your pocket. You had meter number 4 to measure the resistance.
I'm not going to do that. I'm just going to undo these two here. The
really cool thing that I find a lot of students really like is seeing how the balancing act. And you were doing it at 8 volts, Dave, and you had the 2 voltmeters and the 2 resistances, and you can change that system voltage and see the balancing act between the 2 volts. We'll go back to that in a moment. But so there we go. We just confirmed. Meg, if you want to show the split screen. Yeah. So our calculation was 39.6. And when the meter does the calculation for us, we're at 39.2. So we can just demonstrate what the meter is doing inside, how the math is done. And it's very, very fascinating, and it can help students get a better grasp of Ohm's law, voltage measurements, amperage measurements, resistance measurements, and all of that applies very, very well to EVs. Yeah. If you want to go back just once more, Dave, to the balancing act between the 5 volts on one and the voltage measurement.
Yeah. This one movie calculator.
Yes, thank you. The 2 voltage measurements there. I'll move that out of the way. Sorry about that.
So I'm just going to put it back into it. It's one of my leads here, just because they're buried. But anyways, I put that back here. And I still have it. And sometimes what I'll do too as well is I have this set up like this. And then I'll even put to simulate as if it would be a meter.
Yeah.
So then I can go and check other resistors as well, which we'll show you in a second. So not just to the board itself. And that's why I use 8 volts. Because if I used a lot lower voltage, using a higher resistor would be harder to do the calculation, get an accurate measurement. So that ranging, the auto ranging that meter does, usually most meters are up around 8 volts on the applied voltage. So we're going to make 8 volts, and that'll allow us to check pretty much almost any resistor that's out there. So if I'm going to go onto another resistor here, I'm going to go resistor 4. And like Nathan said, we can see the voltage divide on this one here. So we see that we have 1.3 on our meter that we're measuring across, and we see 6.70 on the voltage drop on our fixed resistor. So,
which of course adds right up perfectly to 8 volts.
That's right.
And when the student starts seeing that, and not just once, but repetitively, moving to different voltage values and seeing that balancing act go back and forth, and then when we explain to the students that, well, this is what the meter is doing when it measures resistance, is measuring a fixed resistor, seeing the different voltage drop, and then we can extrapolate from there and explain that the same type of circuits are built for measuring current.
Yeah, and then see, even on the resistor 4, once again, I have 1.318 volts.
Yeah.
And I would divide that by 0.066, which would give me my resistance on that that resistor there. So which is really kind of fun to do. So it gives the students something to actually practice. They use their calculator, they're figuring Ohm's law, and then you can even throw them a batch of resistors, even just like, your regular little resistors there, and then start doing the calculations from that. So that one I'm on right now is 1.3189 volts divided by 0.066. So the 0.066 is my amperage, and then of course my 1.319 is my voltage drop across that resistor. And using Ohm's law, EIR, E over I times by R, I can get that 19.98. And like I said before, taking it that one step further, I can take my meter and measure the actual resistance of those magnets are pretty strong. And we can see that we have almost identical within our calculation. So,
And that's the one that's so telling for students is when they can do the math, both using the amperage, using the voltage drop, and come up with that ohm reading value, and compare it right after with the multimeter. It's kind of an aha moment, I think, for a lot of students.
yeah, and like I said, one other thing you could do is you could take another, just have them, give them a bunch of resistors, and and then they can do the same types of tests. So you can go across the resistors, and of course then they would do a resistance check too. Let's get this guy stick in there. So right now I have 7.28 volts. The voltage drop across the fixed resistor is 0.745, and I'm drawing 0.006 amps. And that's why I use 8 volts here. If you go a little bit lower voltage, some people like to use maybe 5 volts and so on. I recommend stay around 8 volts to allow you to check the higher resistances, especially on some of these resistors. Anywhere from 5 to 8 is fine on the board with these ones because they're fairly low. They're all less than 100 ohms. But once again, if you want to do some external testing with it, I recommend going to about 8 volts on the trainer to apply that, and then have the students actually do the calculations for the math on those resistors.
That's excellent.
So that will conclude some of the setups that we've had. We are working on more, but you can see this hopefully inspires you a little bit to break out the 1919 or one of your Ohm's Law trainers that you may have and incorporate it within your EV programs. Because it's not just for basic electrical, it can have applications into other programs, and like this here, creating these different circuits sometimes will help the students better understand how they work. And so if you have any questions, we're here to answer any of your questions right now.
Yeah, so of course, in all of this, to really apply to the car that we've got behind us and to the cars that you've got in your shop, and that's the idea that we've had behind all of this, is how can we find innovative ways for you to use what you've already got to teach this new technology. So if you have other suggestions, ideas, questions, send them to us. Either if you have any now, we have a Q&A period we can do right now, or send it to us for a future webinar episode.
Great. I think that's about it.
Yeah. If we don't have any questions, we'll...
we should maybe mention about our next afternoon webinar.
Yes, that's next week, Megan, with our colleague Tim Dwyer, who's going to be doing ADAS.
Yep.
Advanced Driver Assist Systems, ADAS technology. So that'll be the 24th, which is a Wednesday at 1 o'clock Eastern time. So we'll be there. Tim will be there to show you guys some new and exciting things.
Great. Well, thank you very much.
Yeah, thanks for joining us.